Hi, I'm Doug Sicker. I'm the co-director of the IRLD. I'm also a professor in computer science and electrical engineering. Um, a little more background on me. I have spent the last 30 years or so working in the technology space, mostly in the area of network systems and network security. I do a lot of work in the wireless and spectrum space as well. I've been in industry and government and academia and in nonprofit positions. Most notably, as it relates to what we're going to be talking about here, is I've held positions as the CTO of the Federal Communications Commission. I was also a division chief back in the 90s in engineering at the FCC, and I was also the CTO in the Department of Commerce assigned to the NTIA. My other background in terms of what makes it relevant to this discussion today is that I spend a lot of my time working with policymakers in terms of getting them to understand the impact of technology and where technology is going. And that's really what we're going to talk about today, which is what we're calling the fifth prism, and more specifically borrowing from Clayton Christensen's work, The Innovator's Dilemma. So what we see when we think about this idea of a fifth prism, as I said, we're really focused here on technology as opposed to some of the other more economic-based considerations of the other prisms. With that said, this definitely has an economics angle, and it really is thinking about how emerging industries can take on established industries and how that looks and what it means from a regulatory perspective. So, as I said, we're borrowing this title, Innovator's Dilemma, from the work of Clayton Christensen, who was a professor at Harvard. He wrote books on this subject and quite a few academic articles as well. And really, though, while I'm going to describe what Clayton meant in his work on Innovator's Dilemma, we're really taking it beyond that, and we're taking it to incorporate some specific aspects of some emerging technology, and not the least of which is the internet, which has been emerging for decades now, but also AI and kind of big data. All of these things combine in a way that really pushes what real world examples of technology and markets and regulation do when they intersect. And I think as we will go through this, you'll see how there's a commonality that we see happening again and again across technologies and across sectors that very much impacts the way that you all can look at what you do on a day-to-day basis. So this, again, idea of innovator's dilemma is what happens when you have the rise of an unexpected competition from some sort of disruptive innovation. And there's many examples of this. Indeed, what we can look at when we start looking across the last even several decades, we can see that there's been massive disruption in communications and how we shop and how we make use of taxis, financial markets, healthcare, a lot of different areas. And all of these, in some way, have been touched by or influenced by the internet and the rise of the internet. And so more of this is happening in a way that we don't even have the sense of what it's going to mean as AI and machine learning and big data come into play, and we start seeing the impact of that on some of these established industries. But more specifically, and as I have on slide 4, what the innovator's dilemma describes is this, again, innovative technology overtaking established industries. And there's a very nice quote, which I'm going to read. And that goes that disruptive innovation describes the process by which a product or service initially takes root in simple applications at the bottom of the market, typically by being less expensive and more accessible, and then relentlessly moves up market and eventually displacing established competitors. As I said, there's been examples of this time and again, as I had just described. And the thing that seems to be really driving so much of this is when this innovator's dilemma meets the internet. And what we see is the internet as being this innovation at the edge and really driving change. So let's take a moment and kind of look at how the internet kind of evolved in terms of perceptions and norms and institutions and practices. There's a great quote by David Clark, which really sums up a lot of the thinking within the internet space. And it goes, "We reject kings, presidents, and voting. We believe in rough consensus and running code." What that really says is they don't have to bow down to the powers of government for the establishment and the standards associated with the internet, how the internet emerges. And furthermore, it's not a very structured, formal process that goes through all of these sort of standards reviews as you would see in some of the other industries or some of the traditional telecom space. Rather, it's more driven by let's roughly agree, and that's the rough consensus. And when I say roughly agree, this is strong agreement by a lot of really bright people who've really given it a lot of thought. So I don't want to make it sound too cavalier, the process, but it is a rough consensus. And more importantly, show me that it works. And that's the concept of running code. So go make this extension to how the internet's operating, and we'll see if it works. And if it works, we'll adopt it. And that really drives kind of the norm of the internet community. And it's very much kind of the ethos of the IETF, which is the organization that really specifies the kind of the standards, as we would say, RSPs around the internet. On top of that, what came some years later in the early 90s was this emergence of the World Wide Web. And the World Wide Web was this mechanism that allowed you to hyperlink to resources all over the internet, making them virtually appear as if they were on your desktop. And the design of that engine of innovation was to have capabilities occur at the edge and take advantage of the internet as a backbone. What that means is that the provider of the backbone or the provider of the network is not necessarily the provider of the service. And indeed, it's almost exclusively not. When we look at how applications develop on the internet, they aren't, the popular ones aren't by the providers of the infrastructure, whether that be the broadband access infrastructure or even the backbone infrastructure. Rather, it's somebody innovating at the edge, creating the likes of things like Facebook or Amazon or Google. And that really drives kind of the culture and drives the kind of challenge, which is if you're able to innovate at the edge and able to do this well, what it allows and what it supports over time is the ability for challengers to come along and disrupt existing well-established markets. And indeed, we've seen this again and again. One of the best examples of kind of disruption has been Uber on something that you all, or at least many of you, regulate at the state level, which is taxi service. Uber has come in through the use of uh, mobile applications over mobile handsets and has allowed for this idea of a new model for taxi. And it really goes under and subverts a lot of the traditional policy and expectation and infrastructure of the taxi service. And of course, it's caused a lot of disruption for a lot of regulators at the state level, and certainly for the taxi industry as well. So the consequence of this sort of innovator's dilemma meets the internet is really one where the technology is going to outpace the regulation. And indeed, the regulation might even inhibit the technology or the markets that could grow out of kind of innovation at the edge and innovation through this kind of very bottom of the market driven kind of moving up the market displacement. The other thing that we see when we think about what this kind of innovator's dilemma means is when you look at the internet and you think about how it's designed, there are some very specific architectural decisions that have consequences. And we'll talk a little bit about that, even though I've already talked a bit about it. But we can see this sort of the implication of the architecture and the implication of how things are operated and the implication of how markets are established as having a profound impact on how disruption can occur and if it should occur. We'll talk a little bit more about this as we kind of dig in to a couple examples. So on slide 5, what we'll see is, we have this regulation in the face of technology change. And as I said, technology really challenges the regulators. It challenges assumptions about cost, about operations, about who's the competitors, the reliability and availability of services, many aspects of what a typical regulated network might operate or how it might be facilitated. And we have seen this implication where what the architecture defines really what is possible. So a certain architecture can either allow or prevent innovation. And as I said, how the internet emerged and how it grew out of dial-up modems and onto broadband and a lot of things where there was prevention of regulatory intervention early on, allowed for an architecture that did support this idea of innovation at the edge. But that doesn't apply universally. We have seen other markets that aren't transformed quite as impactfully, we'll say. A great example is the electricity industry. Certainly there's been a digital transformation. Certainly there's been a change in some of the architecture, but it's been slow. And arguably the operations and the cost structure and the architecture of how electricity is provisioned to customers really is one that resists that change. But even with that, we can still see that there's no question that the internet has created an impact on that industry. If not from the evolution of distributed energy resources like solar cells on your home, but rather something like cybersecurity. Once these electricity grids were connected to the internet, they were now exposed to the threats and vulnerabilities associated with the internet. So cybersecurity has become a huge aspect of this industry. But if we take a step back and we look at how the traditional power grid was designed, which was really a one-way flow from electricity generation out to the end user, we can see that architecture and that design has had some pretty profound implications on how innovation has or hasn't happened in that space. One would argue pretty readily and pretty easily that with the advent of so many homes having solar energy on their roofs and kind of the change in terms of how we think about the use of energy and even the use of energy for driving our cars, that there probably is a different architecture that needs to be in place. And certainly there is. It certainly needs to be a two-way flow, not a one-way flow from generator to end users, but one in which the end users can be generators of the electricity as well, which of course we have. But this growth of a functional two-way network has been very slow. And if we think about what that means, if we had chosen a different architecture, and if we had chosen different constraints in terms of operations, or maybe even the cost structure of what it means to sell energy from the edge back into the network, we might have had a very different evolution of the electricity industry. But the point here is that there is every reason to suspect that an established industry is going to think about what their operations look like, what their architecture looks like, what their business structure looks like, and resist such change that's going to undermine them. And this is exactly what we've seen in the electricity industry. So As we go forward, the thing that is worth you all thinking about is to make use of this kind of prism where you're thinking about how do how does innovation occur and how does it come up through the markets and what could inhibit that and what could allow it is a very interesting spot to ponder. And I can tell you that there's been many attempts at trying to change the network architecture in the telecoms space to enable competition. And it has to be thought through very carefully. A lot of this has failed. It's not has failed necessarily because the idea was wrong, but it failed because the implementation was poor. And the incumbent had every reason to try to resist and fight the change, which is not surprising, right? So as you go forward and you start thinking about what regulation and what policy changes you're making, you really should be aware of what that network architecture looks like across any of the industries that you regulate, because it's going to have an impact on what can happen from an innovation perspective. So to wrap back things to the prisms, um, on the last slide, slide 6, we have kind of the definition of what we'd want you to take a walk away with, which is in the Innovator's Dilemma Prism really talks about the rise of unexpected competition from disruptive innovation. And where this is right now is that we see this kind of whole theme of modern architectures and software and data and AI in the internet impacting all aspects of society. It ranges from kind of our daily lives to our workplace, to the markets, and certainly the regulated networks that you all must deal with. So as you look at this, again, the prism should be one of what does this architecture mean, and how is it going to have an implication on the ability for positive disruption to occur? At the same time, you need to also think about as you put in place regulatory models of rates of return or whatever they might be, that this kind of disruption could make your job much harder. So you do need to think about how these structures are put in place and the flexibility to revisit things as they change, as the market changes from year to year, as technology kind of redesigns the operation of any of these regulated networks. So I hope that is a useful perspective and a useful prism. Thank you.